Okay, project 4. So the issue we're trying to solve here is when we have a given integer from a user, we want to find the additive, persistence, multiplicative persistence, and the additive and multiplicative roots of that given integer. And so in order to start off with this program, we have a Boolean variable called keep going, and we're going to set that equal to true. This Boolean variable is going to determine if the program will keep repeating until the user doesn't want to go anymore. So while keep going is equal to true, which is true, the first thing we do is we're going to have these variables set to 0, and this is so that we can reset these variables when the program is repeated again. We don't want them to persist with the same values they were used before. We want them to reset. So then we have a new Boolean variable called checked for integer error, and that's going to be set to false. And this is used to loop the try and error check we're about to go through right now. So while checked for integer error is equal to false, which is true, we're going to try, and we're going to ask the user to input an integer. Please enter an integer, and if they enter a negative integer, it's going to quit. And so once they've put in a valid integer, checked for integer error is going to be set to true so that we can exit this while loop right here. And then we can proceed on with the program. But if they don't put in a valid integer, say they put in a float or they put in a string, then our accept value error is going to trigger here. And we're going to ask them to please enter a valid integer, and they're going to get asked to input a new integer again. So once they finally put in something valid, we're going to proceed on and check while the given integer is positive. So if they put in something positive here, so we're going to calculate the additive root and persistence and the multiplicative root and persistence. So the first thing we check is when it's a positive integer, is this integer that the user put in, is it a single digit number? So if we have a number like 3 mod 10 is going to equal 3. 5 mod 10 is going to equal 5. So that's a way we can check if it's a single digit. And if it is a single digit, then the additive and multiplicative roots are going to equal the integer itself, and the persistences are going to equal 0. And then we're just going to print the results of that right here. And we're going to break out of this loop. We're going to break out, and then we're going to repeat the program again. But otherwise, if what they put in was not a single digit number, if it's a positive multi-digit number, or as long as it just isn't a single digit number, we're going to have set this variable called multiplicative root check equal to the number they put in. And the reason why we have this variable is because we're going to need it later when we check for the multiplicative persistence, because when we check the root. When we check the additive and multiplicative roots, we want to have two different variables to check, because we're going to use the given integer twice, but it's going to get altered in the additive root. So we need the multiplicative root to use the given integer value without having to ask the user to put in the same value again. So while the given integer is greater than 0, now the reason why we have this is because while we do the additive root calculation, we're going to keep reducing the integer to 0. So once it hits 0, that's how we know we're pretty much done with this. So what we have here is a variable called current digit, and current digit is referring to the rightmost digit of the given integer. So if we have a number like 1234, the rightmost digit would be 4. And in order to find that rightmost digit, we have the given integer, so 1234 mod 10. That's going to give us 4, the rightmost digit. And we assign that to current digit. And so once we find the rightmost digit, we're going to set the given integer equal to the number without that rightmost digit. So if we have 1234, once we find the rightmost digit, we want to take out that rightmost digit. So we just want 123 instead. And in order to find that, we just have the given integer divided by 10. integer divided by 10. We don't want a float here. So now we have 123, and we have a rightmost digit of 4. So then we're going to add that rightmost digit to our running total, which is sum. So this is going to keep looping until it's equal to 0, because as you keep dividing by 10, you're eventually going to get, it's eventually going to converge to 0. So it's going to go through all the digits, so 4, 3, 2, and 1, and then that's going to be our sum is going to be our additive root. So at some point, obviously, the given integer is going to converge to 0, which means that an additive persistence sequence has occurred. So we're going to add the additive persistence by 1. But we don't want to just exit out the loop just yet when it equals 0, because some numbers have more than one additive or multiplicative persistence, so we need to make the given integer equal to our sum, so that this loop can continue until there's no more persistences to deal with. So if you have a number like 1234, the root of that is going to be 10, but 10 is not a single digit number just yet, so we need to find the root of 10, which is just going to be 1. So we need to do this again. We can't just stop. We can't just find it one sequence of the persistence. So if the sum, so if our root is greater than 9, so if it's not a single digit number, and our given integer is equal to 0, then we're going to set the given integer equal to sum, and then we're going to reset sum back to 0. That way we can find the actual final additive root. And then we just print the results of the additive persistence and root. So now we have, now we're going to calculate the multiplicative persistence and root. But before we calculate it, we need to set sum equal to 1. For the additive root, we had sum equal to 0, but for multiplicative, we want it to be set to 1, because we're now going to deal with multiplication here, and we don't want it to equal 0, because if we have a 0 in our multiplication, we're going to get 0 back. So we need to set it to 1 so we don't get a 0. So for the multiplicative root, we do the same calculation, practically the same calculation as our additive root and persistence calculations. The only difference here is that in our running total of sum, instead of adding each individual digit, we're now just going to multiply each digit. So instead of 4 plus 3 plus 2 plus 1, we're going to have 4 times 3 times 2 times 1. And we're going to have the same checks here again. Checking if, our given integer has hit 0, we're going to add 1 to the persistence. Is our, how some numbers have more than one persistence, we're going to keep looping so that we get the final root. And then we just print the results of the persistence and the root. And then we're going to break out of this while loop, because we're done. We found what we needed, and we can just break out of this main while loop. Or not the main one, this one right here. While the given integer is positive. We're going to break out of it once we're done with our calculations. Now, let's say the user did not put in a positive integer. If they put in something negative, we said earlier that if they enter a negative integer, we're going to quit. So, while given integer is positive, since if we have a negative number, this while loop is not going to be true. So we're going to go right to this else statement way at the bottom. Otherwise, so if it's a negative integer, then we're going to set keep going equal to false. And when keep going is equal to false, this main while loop is no longer true, and we don't continue on with the program anymore. And we thank the user for using it, and we exit out the program. So let's try some output now.